The story of the dinosaurs usually goes something like this. Giant beasts ruled the planet until a huge, fiery rock fell from the sky and wiped every single one of them out in an instant. That sudden, apocalyptic timeline is factually incorrect. These incredible creatures dominated the Earth for roughly 160 million years. An empire of that magnitude does not vanish overnight. Their downfall was a slow, agonizing ecological collapse, with asteroids serving as the final strike in a long series of disasters. Long before that rock ever breached the atmosphere, the late Cretaceous period was already suffocating under a severe planet-wide biological crisis. Deep in what is now India, the Deccan traps tore the crust apart. Relentless, massive volcanic eruptions raged for hundreds of thousands of years. This chart tracks global CO2 during the late Cretaceous. Carbon dioxide steadily climbs over thousands of millennia before the impact. This rise in gas forced the climate into unpredictable swings. Temperatures spiked and plummeted, pulling sea levels chaotically up and down. Plants and animals couldn't adapt fast enough. Food webs that had remained stable for millions of years began to fray and snap. The asteroid struck a world already suffocating from volcanic stress, arriving just as the global ecosystem reached its breaking point. Then, 66 million years ago, a rock the size of a city slammed into the Yucatan Peninsula. The immediate aftermath was hyper-violent. Global shockwaves ripped through the crust, triggering towering tsunamis and igniting widespread wildfires across the surface. This ecological pyramid illustrates the true global killer. The impact hurled immense volumes of pulverized rock and sulfur into the atmosphere, choking the sky for months. When the sunlight vanishes, the plants at the base of the food chain die. The destruction traveled strictly up the pyramid. Once the plants were gone, massive herbivores starved, which quickly left apex predators with zero food to hunt. Extinction arrived as a rapid, suffocating wave of starvation, moving mathematically from the soil straight to the top of the food chain. Why did the ancient crocodile walk away from the same catastrophe that ended the dinosaurs? Crocodiles possessed perfect evolutionary traits for a dying world. They had a slow metabolism that let them fast for long periods, an incredibly varied diet, and lived mostly underwater, shielding them from surface fires. Apex dinosaurs were the exact opposite. Animals of this size burned massive, continuous amounts of calories just to stay alive. They required a steady food supply that no longer existed. Dinosaurs also laid enormous eggs directly on the exposed ground. With sudden freezing temperatures, raging fires, and zero food for the hatchlings, entire generations perished before they could even grow. In a severely destabilized ecosystem, extreme strength and massive size became fatal liabilities. Survival favored animals with low energy demands and natural shields from the elements. The premise of total extinction is factually wrong. Look closely at this eagle. Every bird flying today is a direct, living descendant of the theropod dinosaur branch, the same family tree that produced the T-Rex. The dinosaur lineage never ended. They simply shrunk down, adapted to the sparse environment, and conquered the skies. If that asteroid had struck the deep ocean or hit a landmass with less sulfur to choke the atmosphere, the outcome would look entirely different. Less dust means sunlight reaches the surface. Plants survive, the food chain holds, and the resilient dinosaurs likely bounce back from the volcanic stress to keep their crown. For 160 million years, our mammalian ancestors were kept small, forced to hide in the shadows of those giants. Human evolution relied entirely on a terrifyingly precise cosmic lottery. Without that perfectly aimed rock striking a deeply weakened Earth, we would not exist, leaving us to wonder what kind of dinosaur might be building civilizations today.